In a previous activity, what we had done is we had shown that when we have a full balloon here and an unfilled balloon here, and if we open a valve, this is simply a valve that's going to allow air to go from one side to the other side. And when I opened up that valve, the expectation was that they're going to become equal in size, right? Because this is going to be a higher pressure, this is going to be a lower pressure, and it's going to fill until we reach some sort of equilibrium, because that's what happens in science, in the world. We always end up reaching some form of equilibrium. When I did open that valve like that, nothing happened. It didn't. It stayed full. And I can assure you that the valve's working perfectly, that air should flow from this balloon to this balloon, but it didn't. So we explored what happened. We saw the changes of pressure as you increase the balloon, and we made some inferences because of that. So now, though, I wanted to do a little bit of a different experiment using the smart cart, but still related to this balloon activity. So what I did here is I took a balloon and I attached it to the hook of a smart cart. Now, for those that are familiar with a smart cart, they know that these are very, very clever devices, and there's built-in sensors. So in this smart cart, I have a force sensor that's here that I've put a hook. I could put a bumper, I could put a rubber stopper, I could put other things as well, springs if you wanted to get those accessories, but I've got a hook on there, and it's going to be able to monitor how much force is being applied as I stretch that balloon. Also, in the smart cart, it has, among other sensors, it has a position sensor. That's basically an optical encoder that tells me the position of the smart cart very, very accurately. So what I would like to do is, often when we have a values graph, we plot values against time, but the software allows us to actually plot one sensor value against another sensor value. So in this particular case, what I want to do is I want to see the elasticity of this balloon and what happens when I pull that balloon, when I stretch it. And so I'm going to hook on one end here. This is what we call the end stop, and there's just a convenient little thing to hook on. I'm going to hold it on because I know I tried it and it failed me. It came off. So I'm just going to secure it like that, and then I'm just going to pull that cart. But before I do that, what I would like to do is build an experiment. And so I'm going to go in here and go under Build New Experiment. And I go there, and this allows me to pick a layout. I'm just going to simply pick the first one, the simplest one, which gives me a big window. And I'm going to go and look on the graph icon right there, click on that one. And this allows me to put whatever I want in both the y-axis and the x-axis. So on the y-axis, I'm going to plot force, all right? And then on the x-axis, I'm going to default it to time, but I'm not going to stick with time. I'm going to use position. And you may have seen here, if I refer back to that screen, you've got position here and force that are there. And what this allows me to do is set them to 0. So I want my position sensor to read 0. So I go in here, it's now reading 0.09 meters. I'm going to 0 it now. I'm also going to change the sign because I know I get positive values when I go that way. I want to get positive values when I go this way. So I'm going to go there and I'm going to change the sign, and there it is. I've changed the sign. And now I'm going to go and do the same thing to the force sensor as far as 0 in it. I'm not going to change the sign because when I pull on the force sensor, I get the positive values that I would like to have in this particular activity. So I'm ready to go. And so what I'm going to do is I'm going to hit start. Okay, and we're not seeing too much. And I'm going to expand that, and it's going to look like this. And I'm going to pull, okay, and you're going to start to see, whoops, there's the mistake. I said didn't do what I was supposed to do, but here I go. All right, so now I'm pulling. I keep on pulling, it will eventually break. So I'm going to stop there. All right, so go back there. I'm going to stop. All right, so there we've got a little bit of data. And it's a bit messy here at the beginning. That's not really what I wanted to do. I should have remembered to do what I said I was going to do, and that's put my thumb there so it didn't flip off like that. But what's kind of interesting here is you can see how much more force was required initially, or change of force was initially required. This is a much steeper slope, and we've got tools that we can go there and measure it. than what's here. In fact, if I wanted to measure that, I can simply go into a little icon here, right there. Well, first of all, let me select a region. I'm going to select a region. I'm going to just select that region there. All right. Okay, I'll select that region there, and I'm going to look at the slope. And I get a slope here, an M value of 99.9, and then I move that over here, and you can see it changes. So the change of force, and so that sort of gives me a little bit of insight that that it needed the change of force was greater earlier on when I was just expanding it. And I think if you thought about it, you might be able to relate to how that would be when you're starting to blow up the balloon, how it's a little bit harder at the beginning. The other thing too is you can definitely see that there's some sort of inflection point here, right around that point there. It's actually quite linear when you move up. So again, I think that's all kind of interesting, and I think that can relate to the experience when you're blowing up a balloon. Once you get past that hard part, it gets much easier, and rather consistent in force until maybe you get to the very end when the balloon explodes. So what I'm going to do here, though, is I'm going to do the experiment one more time again, because I just don't like all that mess. And this time I'm going to be much more cognizant and aware, and I'm going to put my thumb there. So what I'm going to do is I'm going to go and delete that data. And I do that by going into this icon there. It allows me to go under manage runs. So I don't want to delete the setup. I just want to delete that last piece of data that I had. So I'm going to go and delete last run. And it's gone permanently. I'll never see that again. It's history. All right. So now I'm going to do the same thing. I'm going to hit start. All right. And I'm going to pull. And here we get the data. And there you can see the inflection point that I've talked about earlier. And if I had two hands to keep it really clean, I wish I did, but I don't. I have to do this all by myself. So I just have the one. Now what I'm going to do is I'm going to take a second balloon. And here's a second balloon, and I'm going to work on it a little bit. If you remember when people have a balloon, often what they'll do is before they blow it up, they'll do this and this. And why are they doing that? Well, let's see if we can actually measure that result, or measure the effect on the force. See if there's any relationship there. So I'm going to go and poke a hole, and hopefully I do this well. I'm about 75% successful when I do this. And so hopefully that's off camera. On camera, I'll probably be less successful. All right, let's see how that looks. That's stretched a little bit. All right, yeah, that doesn't look as good as I was hoping it was going to look. Hold on. I really need to get, I'm kind of, let's try it again. All right, there we go. I got what I wanted. All right, and there. I'm going to flip it up here. And then I'm going to press the play. I'm going to go there. I'm going to go there, zero the position. All right. All right, I need to do that, and the force is pretty much zero as it is, but let's just zero it anyways. All right, so I've got that, and now I'm going to hit start. Now the other data has disappeared, but we will get it back. Now I'm pulling it like this, like that. All right, again, we get that little bit annoying backup. And then I'm going to bring back the other data. And so there we have it. Now, unfortunately, I didn't align these up, but we can still look at this data because it's quite interesting. And you'll notice that the first run, that was the one that was done in green. Look at how much steeper that is, right? Look at how much steeper that is, the green one, than it is than the purple one. It would be maybe ideal if we had them start at the exact same point. Obviously, I waited a little bit longer with the green one and got going right away with that, but that's not really that important. What's really important is that slope here. So you can tell by stretching that balloon that you've changed the properties of that balloon. You've changed the elasticity of that balloon. It has less force. And because of that, it had a more shallow slope. So this is just an experiment that I came up because it just occurred to me what we could do with the force sensor that was built in there. I think this is kind of like a STEM activity that you could consider with your kids, and there's probably things I haven't thought about This wasn't something I had ever done before today, but I thought this was kind of a neat investigation. So for those who are looking to using sensors for STEM activities, I think this might give you some insights to some of the potential. Okay, thank you.